Alright, here we are. This is, I guess, more or less what we would be talking about on the first day of an actual, more traditional class. Um, a little different here through the online environment. You get all the thrilling anticipation and eager excitement of the first day of class, all from the comfort of your own home. Before we delve into this, I guess I'll throw a little bit of a disclaimer out there. I'm on, I think, hopefully, the tail end of a cold, which I think is making my voice sound like it's going through some sort of surprise second puberty. And hopefully my hoarseness isn't going to affect the sound quality of this particular lecture. But if it does, email me, let me know. I obviously don't want that to happen, and I'd be more than happy to re-narrate if you think it's an issue. But for now, let's go ahead and assume that it's not, and push on with Chapter 1. So, right, all classes start out this way, right? What is economics? What is literature? What is history? So let's start by asking ourselves the question, well, what is statistics? And there's a lot of ways that you can answer this question. Right before I started narrating this, I went to Google. I typed the word statistics into Google, and it said about 539 million results, many of which, admittedly not all, are going to have some sort of definition of statistics at their heart. So there's lots of different definitions. There's hundreds of introductory statistics textbooks out there. All of them have their own definition of what statistics is. Our own book has its own definition of statistics. And as you're reading through that book, you need to be reading the book as well. You can't rely entirely on these PowerPoints. As you're reading through the book, pay close attention to how our book defines statistics as well. I tend to think of it somewhat simply. I think of statistics as a set of tools and techniques to help provide intelligent answers to difficult questions. Another way of thinking about it is the science of learning from everyday life. That's part of what makes statistics so magical to me. Unlike maybe more theoretical, more abstract mathematics, where it's sometimes hard for us to see where does a squared plus b squared equal c squared, where does that apply to my life? How useful is it really to know that the tangent of x is the sine of x over the cosine of x? Unlike this stuff, I mean, statistics it's all around us, like the smoggy air that we're breathing constantly. I had when I was a graduate student, I had an English professor in my class, and I was confused. I said, well, why as an English professor would you take a math class? Would you take a statistics class? It didn't make sense to me at the time. And he explained to me, he said, well, I'm going up for promotion, I'm going up for tenure, and I have all this information, I have all these numbers, I have this data, I have all these student evaluations that I've accumulated over my lifetime as a professor. And what I would like to do is I would like to make the most convincing, the most persuasive argument I can based on these numbers that I'm worth promoting, that I deserve this tenure. And so he diligently sat through the entire class, did fantastic, of course. And when I saw him a year later, and I asked him, I said, well, how did it go? He said he got his promotion, he got his tenure, and he was nice enough to say that he really felt statistics was useful in helping him do that. I mean, so this is an example just to start with, right off the bat, that hopefully brings some relevance to statistics to us. At some point, we're all going to have to pay our bills. At some point, we're all going to have to pay the rent, which means we're going to need jobs, we're going to need to make money, and part of having jobs, part of making money, is trying to get promotions, trying to get raises, and statistics is one way to help you do that. Not even so much statistics, I guess that's not even the way I'd phrase it, but maybe statistical thinking, right? It's a new way of looking at the world and sort of making sense of it. And that's hopefully what we're going to see as we work our way slowly through this course. Now, there's a lot of parts to statistics. I put a few of them down there in that third bullet point. To apply statistics, we need to precisely formulate our question. We're going to talk about that through the course of this class. We need to decide what data, what information do we need to answer this question. We're going to need to figure out how do we actually go and collect that data. And then finally, and this is really what we're going to spend the bulk of the class talking about, once we've gathered this data, how do we go about interpreting it? So, just like every class, we need to start out with a little bit of vocabulary. I want to make sure that you and I are speaking the same language, that when I talk about a certain word, that it means the same thing to you as it does to me, as it does to our textbook. So let's start with the experimental unit. Um, other books sometimes call this the individual, and you can think of this as a person, an object, I guess sort of like a noun that's relevant to a particular statistical study or experiment. So it's sort of like it's like the fundamental building block, like the atom, if you would, of a statistical study. The variable is the relevant characteristic of the experimental unit that's being measured. Now, you can break variables into two main types. The first type of variables is quantitative. A quantitative variable takes a numerical value. That makes sense, right? The root word of quantitative is quantity. Quantity is an amount, right? An amount is a number. These quantitative variables are often distinguished by having units of measurement, right? That's not always a perfect way of finding it out, but often it does work. So things like inches, things like dollars, things like points, these are units of measurements that might be paired up with things that are quantitative variables, right? For instance, a quantitative variable might be the height of a randomly selected student, right? Another quantitative variable might be, right, the salary of a randomly selected nurse, right? One other example might be the points on, say, a final of a randomly selected exam. Do you think you could think of a quantitative variable on your own? I mean, take a minute. Maybe write something down. Think of your own quantitative variable. It's always exciting when you have something of your own. It gives you ownership of this particular subject matter. Alas, I can't hear what it was, but I'm sure it was a great example. Maybe it was something like the weight of somebody. Maybe it was something like their blood pressure. We were talking about nurses earlier. Maybe some measurement of respiration. I think that's a vital sign that you can measure. Maybe the miles per gallon of a car. Right? There's tons of quantitative variables and examples of them out there. Now, the second type of variable, I mean, you can almost think of it as not quantitative, as not a number. And if it's not a number, well, what is it? It's sort of like a group or a category. We call these types of variables, we call them qualitative. Can you think of any qualitative variables? That is, any variables that you might measure on an experimental unit that aren't numerical? Can you think of any? Geez. It's a good thing we're not in the classroom. I'd be embarrassed. I'm having a hard time thinking of some. Why don't you write one down? There's lots of examples. I think one that students tend to offer a lot in the classroom is gender, right? Gender is a qualitative variable, male or female. Not really any ranking to them. It doesn't really have a numerical quality to it. Another example might be someone's religion, right? Christian or Catholic or atheist or agnostic, right? Those are possible religions that people could be. Color, for instance, is a qualitative variable. You ask someone their favorite color, they give you some sort of response. The variable you're recording, their favorite color, that's a qualitative variable. Let's do an example just to make sure that we have the basic idea. So say that maybe we're like a radio station, like the Westchester radio station, or I guess even better, maybe like the Westchester newspaper, and we're going around, we're randomly selecting, we're accosting local students, and we're grilling them, we're interrogating them, we're asking them to give us the following information. We say, what's your name? What's your gender? What's your class level? Hey, how much money do you expect to make after graduation? And I'm not really sure why we're doing this, but maybe we pull a little ruler out and we measure their height. So my first question to you is what are the experimental units, right? What are the sort of fundamental building blocks of the study? My second question to you is what are the variables? And then also for each of these variables, classify each as quantitative or qualitative. So the answer's on the next slide. I'm gonna turn the page in just a moment, but I want you to take at least a few seconds to sort of think this through. Don't even necessarily have to write down your answer because it's going to be written down for you. But at least think it through. What's the experimental unit? What are the variables? And try to think: is each variable, is it quantitative or is it qualitative? I do have to admit, it's somewhat boring sitting here staring at my monitor waiting for you to do this, so I am going to go ahead and go to the next slide. So here are the answers. Hopefully my answers agree with yours. Now, a little trick is sometimes it's easier to do this backwards. That is, it's almost easier to start with the variables. What were the variables? The variables were expected salary, height, name, gender, and class level. Let's take a moment and put them in their appropriate categories, right? Expected salary, how much money you're making. That's units, right? Units of dollars, and it's also a number, right? It's a quantity, so it's a quantitative variable. Height as a unit has inches associated with it. It's also a number, right? So that's a quantitative variable. Things like name, those aren't numbers, hence qualitative variables. Gender is not a number, hence a qualitative variable. Class level, not a number, hence a qualitative variable. Now, when you're trying to figure out what the experimental unit is, if you've already figured out the variable, you can sort of ask yourself this question. You say, okay, the variable is expected salary. It's the expected salary of what? Right? The answer to that question is your experimental unit. If you say the variable is height, then you ask yourself, well, the height of what? Right? If the variable is gender, you say, well, the gender of what? And the answer to all of these questions, right, is it's the expected salary of a student, the height of a student, the gender of a student. Hence, our experimental unit is the students, right? Really, the experimental unit is a single individual student, but I pluralized them, and so I pluralized the students as well. Good job, us. Let's carry on. Now, in statistics, we always want to test any question of interest with appropriately gathered relevant data. We mentioned that, I think, on the very first slide as we started this. And so an important question then is, well, how do we do this? How do we go about and appropriately gather data? That is, right, where is it that data comes from? It doesn't come from the data fairy, although it would be cool if it did. Now, a few more definitions. The first definition is that of population. So a population in a statistical study, it's the entire group of individuals about which we want information. The sample is a part, a segment, a subset of this population from which we actually collect our data. And the third bullet point, the sampling design, it's a description, it's an algorithm, it's a method about how we're actually going to go about and select a sample from the population, right? The sample's a part of the population. The sampling design tells us, well, how do I decide what part of the population it is that I should include you, that we want to look at? Now, you might ask yourself, well, what's the point to all this? What's the point of sampling? It's a smart question, particularly when you keep in mind that generally, as lovers of life, as those that want to inquire into the nature of the universe, what we're generally interested in is we're generally interested in the characteristics of a population. That is, right, we might want to know the eating habits of all great white sharks, right? We want to be able to in some way characterize or describe the entire species, right? Not just Joe or Bill or Jane, right? These individual great white sharks that may be swimming around up in our local New Jersey beach. We want to know about all of it, the population of great white sharks. We might be interested in, right, not so much the opinion of one person or another person, right? Because that doesn't really impact politics. What we would be interested in is some sort of larger aggregate opinion. Maybe the opinion of all high school students on some particular political topic. Right? We have a presidential election kind of coming up, so maybe that could be our topic of interest. And also, right, we might be interested in, right, the mean gas mileage of all 1998 Honda Civics, if we were thinking about buying one, for instance. So what I'm getting at is it's often the population that we're interested in. So why bother sampling? Why does this concept of sample even exist? Good question. Well, here's the answer. Even though we're interested in characteristics of the population, it's generally unrealistic, if not impossible, to record information on the entire population. I mean, go back to that great white shark example, right? It would be very unrealistic, impossible, probably even a little bit dangerous for us to strap on some scuba gear and track down every single great white shark scattered throughout the world, right? buried deep down in the Mariana Trench, follow them around for a few days while recording their eating habits. Very impossible to do, right? Track down every 1998 Honda Civic, even if somehow we had like these kind of all-inclusive DMV records, even if we knew where they all were, it would take so much time and energy and man/woman power to track them down, to drive them around for a while, and be able to record reliably what the gas mileage is for that car. Even the second example, maybe we could look at the whole population, for example, too. That is, maybe we could somehow actually gather the opinion of every high school student. But if you just jump that one level to, well, what are the opinions of all Westchester students? Well, now it becomes considerably harder, right? Because it's not easy. We don't have a homeroom or something like that to track down every student. We have some people come during the day, some people come during the night, some come only on Mondays, some come only on Fridays, right? Some check their email, some don't check their email, right? It would become very, very difficult to do that. Think about trying to get the opinions of everyone, say, in Westchester Borough or the state of Pennsylvania, right? Or a much more ambitious task, right? The opinions of all voters throughout the country on a particular political topic. So I mean, this is the answer to our question: why is there a sample? There's a sample because we live in a world, unfortunately, of limitation. We live in a world of limited resources, limited money, limited people, and because of this, even though it's the population we're interested in, we just don't have the resources to look at the whole population. Rather than give up, we never give up in Math 121, we say, well, I can't look at everything, let me look at some of it. That is, let me look at a part of this population. Does that make sense? If we lived in a world where we could track down every great white shark, if we lived in a world where we could track down every 1998 Honda Civic, you might think that would be an exciting world because it would imply some sort of superhuman powers. It would be like a world of superheroes. But in fact, it would be a sad world, because if we lived in that world, we would have no need of statistics, right? I mean, this is sort of the root of statistics. Statistics is a way of addressing this tension, this sort of contradiction that we want to be able to make conclusions about a population, yet at the same time we can't look at the entirety of the population. Statistics is all about how we get around that. It's all about how do we take a sample, what's the right way to take a sample, and then what can my sample tell me about the population. Let's go on. Oh, this is just what I said. Because of this, we only look at a portion of the population. As we said before, we call that portion our sample. A natural question, right, where this leads us is, well, how do we pick a sample? That is, once we've sort of glumly accepted the fact that we can't look at the whole population, that we have to take a sample, how do we decide what portion of the population are we going to look at? Well, there's a few steps to how we go about doing this. One is that we need to completely define our population of interest. The second is we need to completely define our variable of interest. And the third thing is, once we've done that, we need to actually go about and figure out how to choose, how to select our sample. Now, let's just kind of talk through just one example to maybe get at least a bit of an appreciation that these are non-trivial tasks. So this is something Bureau of Labor Statistics has to gather this data quite regularly. I think monthly, but maybe even more regularly than that. So consider like an unemployment survey. That is a survey that our government has to constantly do to determine what proportion of the American population is unemployed at any given time. Now, what did we say? We said to go about doing this, we need to clearly define a few things. The first thing is we had to clearly define, well, what's our experimental unit? Well, I mean, it's somewhat easy to start with, right? You would say, well, it's a person, it's an American. I guess we're interested in the American population, but there might be more to that as well, don't you think? For instance, my niece, she's I don't know, I'm not sure anymore, 8-ish maybe younger than that, 7-ish, and she is unemployed. Last I looked. But I think most of us wouldn't consider that a blight or a black mark upon the workplace. My beloved 86-year-old grandmother, she's not working either. Again, I think most of us wouldn't think of that as some sort of indicator that there's something wrong with the economy. So the experimental unit, and more so I guess really what we're getting at, this population of interest, is it's a little bit trickier than just right, an American. Right. For one, we might have to put some sort of age restriction on there. Maybe we would say the population of interest is all Americans between the age of, say, 18 and I don't know. Right. It's harder to come up with an upper bound. Should it be 60? Should it be 65? I think 65 is kind of like this classic retirement age, but there's plenty of people that are over 65 and are working. There's plenty of people that are over 65 that are not working, but they would like to be. What about another question, right? What if somebody wins the lottery? Yeah, no, good for them. And they're now millionaires, and so they're not working. Would we consider that a mark against the economy? That they just have a ton of money now, and because of that they don't need to work, and they're kind of lazy, so they're not going to do it? Yeah, probably not, right? In fact, that's actually the heart, I think, of how the Bureau of Labor Statistics sort of defines the population. Is they sort of define it as, right, Americans that are looking for work, right? That's actually the key definition. There's a little bit more to it, and hopefully just what we've talked through is at least enough to give you an idea that that this is a challenging question. What was the second thing? I think the second thing was we had to clearly define our variable of interest. So what's our variable of interest? Our variable of interest at its at appearance, it's somewhat simple, it's somewhat straightforward. You're either employed or you're unemployed, right? Now, maybe we need to come up with, well, what does it mean to be employed? Right? For most people, it's straightforward, but we could certainly imagine that there exists, out of all the millions and millions of Americans, some sort of ambiguous gray areas, don't you think? Like, what if you're a contractor? You do contract work. You're an electrician, and you haven't had anyone call you for a few days, for a week, for a couple weeks, right? At what point do you sort of become unemployed? I don't know, right? That's sort of, it's not obvious what the answer is to that question. Go back to our millionaire, who maybe instead of taking a lump sum is regularly collecting money. Is that person employed? Are they unemployed? What about a teacher who it's during the summer and they haven't worked for the last 2 months? Are they employed? Are they unemployed? Right? It's again a non-trivial question, and it's something that it's so important is done before you start any important statistical study. Is you clearly define the population, you clearly define the variable of interest. That is, if you were the hand of God and you reach down and you grab an American, it may be this lottery winner, it may be your niece, it may be your grandmother, it may be you, right? And you need to be able to say, for whoever it is that you've grabbed at random, this person is a part of my population or they are not a part of my population. You need an ironclad rule that will tell you for every person, no matter how quirky their life circumstance, whether they're part of your population of interest. Then, if they are part of your population of interest, you need another ironclad rule that will tell you, for this particular person, they're employed or unemployed. No matter what sort of crazy life story they tell you about their working history and what's going on in the present, you have to be able to say, unequivocally, this person's employed or not employed, and you need a rule that is so specific and so perfect that if your next door neighbor were to do the same thing, they would come to the exact same conclusion that you did. And hopefully this example is enough to show you that there is some complexity to doing that. In fact, I teach a graduate class, an entire class, just on this topics in these materials. There's a lot of depth to it. We're really just scratching the surface here in Math 121. So I need an orange juice break, and so it's a good time to stop. We're going to go ahead, we'll finish off Chapter 1 in the next set of PowerPoints, and we're going to spend that time talking about what that third bullet point was, which was that idea of sampling design. That is, once we defined our population of interest, our variable of interest, how do we go about actually selecting the sample from the population? Talk to you then.